Hello everyone. Today we will start our new chapter from statistics, moment, skewness and kurtosis. So first is moment. Let x1, x2, x3 up to xn be a set of in observation and let a be any constant. Then the rth moment of the distribution about a is defined by rth moment about a equal to 1 by n summation I equal to 1 to n xi minus a to the power r. Thus, the first moment about a equal to 1 by n summation I equal to 1 to n xi minus a. First moment about a means where r equal to 1. Second moment about a, that is 1 by n summation I equal to 1 to n xi minus a whole square, etc. In case of the frequency distribution, the rth moment about a equal to 1 by n summation I equal to 1 to n fi into xi minus a to the power r, where if I is the frequency of the sample value xi, I equal to 1 to 3 up to n, and capital N equal to summation I equal to 1 to n f of I. Now the question, find the first three moments about 8 of the data 6, 7, 10, 9, 12. So this is the where this is a problem where only samples are present. So here we will use the first formula, this one where only the samples are present, there is no frequency. So here the formula is this one, summation xi minus, just see here a equal to 8, here a equal to 8, that is the first three moment about 8, so xi minus 8. So here first three moments, that means first moment, second moment and third moment. So first moment where r equal to 1, second moment r here r equal to 2, and third moment r equal to 3. So here whole to the power r divided by sum of number of observations. So here number of observations are 5, 1, 2, 3, 4, 5. So this is a formula. If we are going to find first moment, put r equal to 1. If we are going to find second moment, r equal to 2, and third moment, r equal to 3. So in this sequentially, we will get the first moment about 8, the second moment about 8, and the third moment about 8. Next is raw moment. So raw moment, what is raw moment? So moment will be raw moment when a equal to 0. In the formula of moment, if we put a equal to 0, that means moment will be shifted into raw moment. So the moment about 0 are generally called raw moment, and they are generally denoted by mr dash. So for simple observations, mr dash equal to 1 by n summation I equal to 1 to n xi to the power r. And for sample having frequency, 1 by capital N summation of I equal to 1 to n fi into xi to the power r, where fi denotes the frequency of the sample value xi and capital N equal to sum of frequency. And keep in mind m0 dash equal to 1 and m1 dash equal to x bar, which is mean of the distribution. Next is central moment. The moment about mean, arithmetic mean are called central moment, and it is denoted by mr. It is denoted by mr. So the rth moment, so actually in the formula of moment, here a equal to x bar. So mr, that is for simple observations, 1 by n summation I equal to 1 to n xi minus x bar whole to the power r, and this one 1 by capital N summation I equal to 1 to n fi xi minus x bar to the power r. So where fi is the frequency of the sample value xi, I equal to 1 to n, and capital N equal to summation of I equal to 1 to n fi, that means sum of frequency. And obviously we know that m0 equal to 1, m1 equal to 0, m2 equal to sigma square or s square, which is variance of the distribution. Next is relation between central moment and raw moment. So here m0 is always 1. No need to prove if we are having any value where we have to put the value of m0. So we can directly put m0 equal to 1. m1 equal to 0 and here m2 equal to, so m2 equal to m2 dash minus m1 dash whole square, m3 equal to m3 dash minus 3 m2 dash m1 dash plus 2 m1 dash whole cube, m4 equal to m4 dash minus 4 into m3 dash m1 dash plus 6 m2 dash into m1 dash whole square minus 3 m1 dash whole to the power 4 and so on. So this three formula we should remember, the relation between central moment and raw moment. Next is effect of the change of origin and the change of scale on moments. Let x1, x2, x3 xn be a set of n sample having the frequencies f1, f2, f3 fn respectively, and let yi equal to xi minus a by b, where b must be not equal to 0, I equal to 1 to n, then m1 dash equal to b into m1y. So what is the meaning of this? Here meaning is this is the, so we know that mr represents central moment. Let's check it. Just see here, mr represents central moment. So this is the first central moment with respect to x. And here b equal to m1 dash y, and m2 dash x means here second central moment with respect to x equal to b square, m2 dash y means second central moment with respect to y, and m3 x means third central moment with respect to x equal to b cube, m3y means third central moment with respect to y, m4 x means fourth central moment with respect to x equal to b to the power 4, m4 y means fourth central moment with respect to y, and so on. So in this way, so these are the relation between x and y scale based central operator, central moment. Now if we are going to write for raw moment, so what we can write, m1 dash x equal to b m1 dash y, m2 dash x equal to b square m2 dash y, m3 dash x equal to b cube m3 dash y. Okay, so corresponding this way, this type of formula also we can write. Okay, now the question, find the first three raw moment and central moment for the data 2, 5, 8, 9. So here we have to find out raw moment and central moment, but we will not find out individually or separate raw moment, central moment, because we know that we have the relation between central moment and raw moment. So we will take the help of that relation. We will find out one moment, and then after finding this with the help of the relation, we will find out another moment. So now tell me, between raw moment and central moment, which one we are going to find first? So here answer will be raw moment. Why? Because in raw moment a equal to 0, and in central moment we have a equal to arithmetic mean, that is x bar. So between two this, to find the raw moment is easy. So that's why you will find out first raw moment, then with the help of relation between raw moment and central moment, we are able to find out the central moment also. So first three raw moment, so what is the formula? Formula is summation xi bar n. Okay, so here r, so first three moment means r equal to 1, r equal to 3, r equal to 2, r equal to 3. So for this reason, first make the table. X we need actually sum x square, sum x cube. So accordingly just put all the data and find out the sum value of x, sum value of x square, sum value of x cube. So just see here m1 dash, m2 dash and m3 dash. So that means raw moment we found. Next thing is central moment. So how do you find? With the help of the relation between central moment and raw moment, we are able to find out the remaining value. Just see the formula. This formula we should use here. These two formula we should use here. Since here only m1, m2, m3. So no need to find out m1 separately. We can easily write m1 equal to 0. And then find out m2 and m3. m2 means m2 dash minus m1 dash whole square. m3 means m3 dash minus 3 m2 dash m1 dash whole square. Okay, just put the value from the above lines, you will get the answer. Next thing is find the first, the second and the third central moment of the frequency distribution of expenditure rupees per month given below. So just see that in the previous problem and this problem is different. Why different? In previous problem we have only the observation, and in this problem we have class interval having frequency. So same as before, first we have to find out raw moment, then with the help of the formula we will find out central moment. So before finding again raw moment, just see here class interval is there. So whenever, already I told you, whenever is class interval is there, there is some change of scale property, change of origin will arise. So first here we should write the class interval this way. Then there is no gap, so no need to find out the class boundary. Next thing is frequency, we can write, and class mark. Class mark is 3 plus 6 divide 2, 6 plus 9 divide 2. This way we can arrange. Next thing is, which is very important, change of scale property, yi equal to xi minus c by d. So what is the value of c here? Just see. This is the between point 13.5, so c equal to 13.5, and difference is 3 difference, so divided by 3, so minus 3 minus 2 minus 1 0 1 2 3. Okay, so these four columns are very okay. Next column, what will be the next column? Okay, so again we are go back to the change of scale property. So change of scale property says first we have to find out with respect to x, then we are going to find out with respect to y. Okay, so for finding with respect to y means we have to find out m1 dash y, because we are going to find with respect to y. Same way m2 dash y, m3 dash y. Okay, so m1 dash y means what we need, what we need, just see, m1 y means summation of yf by n. Same way m2 dash y, summation of y square f divided by capital N. m3 dash y, summation of y cube f divided by capital N. Okay, so that means we want here summation yf, summation y square f, summation y cube f. Just put the value, and find out the sum value. So we will get minus of this 1.958 and minus of 3.224. This is not the end. That we got raw moment with respect to y. Next we have to transform in terms of x by using change of scale property. So here m1 dash equal to 3 into y, because this is b into m1 dash y. So what is the value of b? Value of b is 3. So here 3 into m1 dash y, this one. Next is m2 dash y. m2 dash is b square into this one. Okay. Next is m3 dash x, b cube into this one. You will get this one. So these are the raw moment of the given problem. But question is, find out the first, second, third central moment. So central moment, m1 equal to 0, no need to change. m2 equal to m2 dash minus m1 dash whole square. So just put the value, and m3 means m3 dash minus 3 m2 dash m1 dash plus 2 m1 dash whole cube. So just put the value, you will get the answer. So this is 17.39 rupees cube. Okay. Next is beta coefficient. Beta coefficient generally denoted by beta 1, beta 2, which are defined as beta 1 equal to m3 dash m3 square divided by m2 cube, and beta 2 equal to m4 minus m2 square. So what is the meaning of m3? M3 means third central moment, M2 means second central moment, M4 means fourth central moment. Okay, so these are the formula of beta 1, beta 2. Notice beta coefficient are never negative. Beta coefficient are pure numbers independent of origin. A symmetric frequency distribution is said to be leptokurtic, platykurtic, and mesokurtic according to the beta 2 greater than 3, less than 3, or equal to 3. And beta coefficient are generally used for measuring skewness and kurtosis of a distribution. Next is gamma coefficient. Gamma coefficient generally denoted by gamma 1, gamma 2. So here gamma 1 represent root over of beta 1, gamma 2 represent beta 2 minus 3. So where beta 1, beta 2 are defined above. Now note, gamma 1 will have the same sign as M3. Gamma 1, gamma 2 are pure numbers but may be positive, negative or 0. They are used as measures of skewness and kurtosis of a distribution, where skewness equal to, that is gamma 1 root over of beta 1, already we know that. So this one equal to m3, actually m3 square to the power half, so 2 to cancel out. So m3 divided by m2 3 by 2 equal to m3 by sigma cube, or we can write m3 by s cube. We know that m2 equal to sigma square equal to s square. And Kurtosis, that is gamma 2, beta 2 minus 3. Beta 2 means m4 by m2 square minus 3. So it will be m4 divided by sigma to the power 4 minus 3. So also we can write m4 by s to the power 4 minus 3, because we know that gamma square and s square are same. So distribution is said to be positively skewed when gamma 1 positive, negatively skewed when gamma 1 negative, and equal to 0 when the distribution is when the gamma equal to 0, the distribution is known as symmetric. And distribution is said to be leptokurtic when gamma 2 greater than 0, and here platykurtic less than 0 and equal to 0. Different measures of skewness. Pearson first measure. Skewness equal to mean minus mode divided by standard deviation. Pearson's second measure. Skewness equal to 3 into mean minus median divided by standard deviation. Bowley's measure. Skewness equal to Q3 minus 2Q2 plus Q1 divided by Q3 minus Q1, where Q1, Q2, Q3 are first, second and third quarter respectively. Next is find out the skewness and kurtosis of the series by method of moments. So here class interval having frequency. So first is class interval. Here we have written 0 to 10, 10 to 20, 20 to 30, 30 to 40, and here frequency is 1, 3, 4, 2. So first thing is find out the class mark. 5, 15, 25, 35, but just 0 plus 10 by 2, 10 plus 20 by 2, 30 plus 50 by 2, 30 plus 40 by 2. So next is XF. XF is just 5 into 1, 15 into 3, 24, 5 into 4 and 35 into 2 equal to 70. So here the sum value is 220. So x minus x bar. So x bar is, just see here, x bar is sum of xf by sum of f, that is sum of frequency. 220 divided by 10, that is 22. So here x bar equal to 22. So next column is x minus x bar. That means uh, if you write here, it will be better. Just 1 minute. X minus 22, this one, and this one x minus 22 square into f. This one x minus 22 cube into f, and this one x minus 22 to the power 4 into f. Okay, so m2 equal to f into this one, the sum of this one 8 at 10 divide 10, that is 81, and this one m2 equal to minus 144, this one 14817. So what is the question? Question is find the skewness Kurtosis. So m2, m3, m4 we have done. So according to the formula of beta 1 and beta 2, so just put the value. Beta 1 is m3 square by m2 cube, this one. Beta 2 equal to m4 by m2 square, this one. So the skewness is gamma 1 equal to root over of beta 1. That means root over of this. So value is 0.198, and Kurtosis is beta 2 minus 3. So beta 2 equal to this. Okay. So according to the problem, we can say also nature of the distribution. So if gamma 1 is positive, negative, we can conclude that which type of skewness we have. If we have Kurtosis minus or plus, accordingly kurtosis which type also we can discuss. Next is, in a frequency distribution, the first four central moments are 0, 2.5, 0.7, 18.75 respectively. Find the skewness and kurtosis, hence explain the nature of the distribution. So just see that here M0, here M1, M2, M3, M4 all are given. So no need to find out M2, M3, M4 individually. So just put the formula. So m2 b1 beta 1 equal to m2 square divided by m2 cube. Just put the value, you will get the 0.031, this one, and beta 2 equal to 3. So beta 1 equal to root over of gamma 1 equal to root over of beta 1, that is 0.177, and gamma 2, that is beta 2 minus 3, this is 0. So we know that when gamma 1 is positive, we can say positively skewed, and when the gamma 2 is 0, the distribution is mesocarty. So in this way, according to the value of skewness and kurtosis, that is beta 1 gamma 1 gamma 2, again I repeat, according to the condition of gamma 1 gamma 2, and the value means positive value or negative value or zero value is there for skewness kurtosis, also we can explain the nature of the distribution. Okay, so in this way we can easily find out the skewness and kurtosis, and also we can say that the nature of the distribution. Okay, so next class we will start with another chapter. So till then, bye bye all of you.